Well, as promised, I said I'd do a Truma video. Well, what you see on the screen, you've got my Truma dashboard. So you've got this is how I've coded my Truma. Um, this is just for display only. The code that I made for the device is here. So this is the device I made. It basically goes in the middle. This is my prototype device, which is my only device. Inside there, you've got a ESP32 connected to a mini circuit board to make things a little bit easier to connect wires to. On the far left hand side, you've got a voltage regulator that takes the 12-volt feed that comes from the Truma to power the controller. You tap into it. Well, I tapped into it. And then it gives you a nice clean 5-volt output. Plus it gives me a nice clean 3.3 volt output. You need a nice clean voltage. You don't really want to be sticking a dirty voltage or something with voltage spikes. So you just get a nice... The voltage regulator cost, I think it was about £3 for 10 off of Amazon. You don't have to buy anything expensive. Then you've got the ESP32. I bought that specific board because I don't know, it was just the one they sold. It's the I'll put the specs down later on of that board, but it's basically just a straightforward with a programmable ROM. I do have the firmware which I've compiled, and that just needs to be put onto it. And once you put that firmware on, that talks to the LIN bus converter, which is the next one next to it. So Truma talks in LIN bus. It's very, very similar to CAN bus, but a hell of a lot slower. So if you want critical stuff to go backwards and forwards, you'd either use a CAN bus because it's quicker. But a LIN bus, you can have quite a few devices connected to a LIN bus. But what I've done, I've took the negative from the far left hand side off the voltage regulator and brought that over to the input side of the LIN bus. And then if you see here, I've got it's basically an RJ12 or an 11 cable. It's the old school phone cable or network cable, but it's the 4-pin one instead of the RJ45. I've got that coming out to a splitter, and the splitter connects into the Truma CP panel, and then it's basically the man in the middle. So all communications go to either if the control panel's used, it sends a communication on the LIN bus, and everybody gets that message on the LIN bus. And retrospectively, if you send something from my device to the LIN bus, all devices detect the signal and then respond accordingly, and changes the settings on the screen or on the computer. So that's basically the device. Let's see if I've got some better photos of it. So this is as I was building it. So I don't know how well that picture's going to come out. That's me programming it, and that's the LIN bus converter. It's obviously taken a negative from the thing because these are two positive connections, so it's a high and a low connection as far as I'm aware. And then this will be the common ground, and then they go into the ESP32 via a couple of ports. This is basically a LIN bus to serial adapter, so it gives you a serial, something that's easily readable and manageable in a computer software. And we'll just do one more. Let's see what we got here. That gives you yeah, that's a better one. Oh. Why is it not zooming in? So that gives you an idea of how I've connected it up. I can give out, if people want to make these themselves, they're more than welcome to. I'll quite happily dump the firmware somewhere and the nodered application. So the firmware on this device, all it's there to do is take the Truma information and put it to MQTT. That's all it does. So then it listens on the MQTT and it and sends out commands on it. So if you change a setting on the Cerbo control panel, then it sends the message out. If you change it on the Truma control CP panel, it sends a message to Limbus, and then this listens to it and then updates the Cerbo control panel. So it's quite a technical device, but basically it's in there, it's running, and I am willing to give out the software and the code and stuff like that. It's not a problem. So that's that device. So all that does is send stuff to this. So this is the MQTT Explorer, and what it's doing, it sends all the data that it can collect from the Truma and sends it to service. So then on the MQTT Explorer, and in here you'll have whether it's on the clock, current room temperature. There is going to be more obviously as you go along, so more will come in. If I change something on the Truma control panel, which would be one of these, so if I change something on here, set the temperature to 18, it'll change here in a second. Yep, that's changed. So then we should have a change in here, a room temperature target change. So that's just literally sending messages backwards and forwards, and then it does what it needs to do with that message and then sends it to the Truma. So the Truma's doing its thing. But with this, you can quite easily use this now to get the information you want into basically the Cerbo. So when you click on here, it'll give you the topic, which is service, Truma, control status, electric power level. So that'd be for whether you want 900, 1800 watts on electric, or if you want the room target temperature. See, I've changed the temperature just now, so it's going to show an update, and it'll even give you a graph of as and when you change it. Plus, in the where are we? In here. So if I change that temperature to 21 or 20, what we'll see, give it a second. There you go, the temperature's changed in MQTT. So that's how I've implemented the information. So if I turn that back down now to 15, it's going to get the message. And it got the message, so now it's dropped down to 15. I think. There you go. So it does take a little bit of time to drop down, but right. So to get these here in the switch panel, what you have to do is, first of all, you need to create something like this to actually first of all be able to manage the Truma, all the bits and pieces. So ignore that at the moment. Let's just put that there. Bring that back. Right, so all these here, these blue boxes, are the information in the Truma. So this is the information boxes. The rest of them are all touch buttons. So these are just information or text boxes. So it's taking the information from Truma, water temperature, target, like I showed you a second ago, and then it's spitting it out, and then you can format it in the way you want it to format. You can change the fonts, you can change the text size, you can change the text color. It's all completely up to you what you want to do on that, whether it's centered on label and value on top of each other. Then you can put, so you get the message value formats. You have message payload, but then you can put a comma, a high comma, centigrade, or you can, so you at the end of the thing here, it actually shows you whether it's centigrade. If you see, so that's those bits. Then you get the temperature slider. So you've got a slider, it tells you what range you want to have. So you can have slide between 5 and 30. With the Truma, you should always slide between 5 and 30, because 30 is the max and 5 is the minimum, and 0 is off. There's no 1, 2, 3 or 4 in the Truma code. Well, I couldn't find it with the code sniffer. So then when you want to send it, you send. So if I change that to 20, why is it on 19? So I change that to 14, and when I change that to 14, it sends the message 14 to this number, to this address. Truma, service Truma set target temperature / room. So once you've sent it to it, it then comes back in here, in the target temperature, will then spit out a new message in here. And then to get it into the Truma, you create a virtual switch. So the van temperature, again, is a slider. So I'm just working on something to get that to change this one. So it won't take me long. It's not like in the phrasing that I'm using. But then again, you set your temperatures on here. Steps 1 degree. There is other different settings that you can send it in this window here. And gives you a bit of information what the Trumas, what the node's expecting or is going to come out. So you can either what it's expecting to go in or what it's expecting to come out. So again, with the heating on off switch, it's just a straightforward toggle switch. You can either have temperature set point, step switch, drop down, basic slider, all the different bits and pieces, even RGB control, bilge pump, free state switch, momentary, and then you need to know, cancel that, what this is sending. So if that button's pressed, off is sent to this message, so it turns the fan off, so heating will be turned off. So if I send an off into here, it'll come down this and imaginarily press this button, because this will output a or 0 or 1. So 1 is on. I'm thinking, yeah, no, yeah, 1 is on and 2 is off. Sorry, no. 0 is off and 1 is on. Comes out the heating off, and then it needs to switch the 1s and 0s to where they need to go. So if I'm turning the heating off, then it sends a 1 that way, sorry, a 0 that way, which then is imaginarily you pressing that off button, and then the word off is sent with the message topic into the fan mode, whichever, go to heating mode, so it gets sent into here, yeah, and then that turns the heating off. If I press on, then the heating on comes on, so then a 1 comes out of here, goes into the switch. I'll move that 1 so it comes out the output 2, so it comes out this second output, and then that comes down and presses the eco button, so and the word eco is sent down into the heating mode node here. Same with the hot water, on and off, so you get 1 or 2, yeah, on or off, gets 1 or 2, sorry, 0 or 1. Then it goes into your switch again, sends the 0 or 1 to its relevant paths, so out of the 2 different outputs. So then you get your heating switch off, so that's your hot water off, and then it sends a 0 to the hot water, because the hot water requires a 0 to say it doesn't need any hot water, 0 degrees. And the same with power selector. So the power selector is a little bit more complicated, but it's not a problem. So you tick your options, have what you want, whether you want 4, 5, 6, 7, and it adds them up here. Then you just give them the name. So then out of there you'll get an option. You probably get a 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, depending on which option it is, and then you just send out the relevant wires to the relevant power modes, and then it's an imaginary presses again. And so when you got gas, it sends the word gas to the Truma, and then it set the Truma to gas. Or if you want 1 kilowatt electric, you actually have to tell it you want 900. So 900 watts. And the same with the 2 kilowatt, you have to send it the word or the numbers of 1800 watts to get your 2 kilowatt value. I'm not sure why it was 1800, but that's, I think it probably is only an 1800 watt element, because that's when you sniff in the Truma's LIN bus and actually seeing what's going on, that's exactly what it shows. So that's the message it's looking for, so that's the message you're going to send it. I mean, it does look complicated, but I'm willing, if someone wants to make one of these themselves, I'm willing to share all my workings in a GitHub repository, so you can then download it and then yeah, upload it to your own device. Obviously this code here wouldn't come on the device that you make. I would export this whole page, so I'd export current flow, or cancel that, I'll just go that lot there, select it all, export, selected nodes, so it's giving me all the selected nodes there. I'll go download, Truma I'll save that into my downloads, and then that'll save a JSON file, and then you start off with a blank screen, and then all you do is import nodes, select file to import, downloads, and it should be in Truma. And then it's going to import all the code, all in JSON format, so everything's there. And then you just put import, and then it'll import the whole lot into a new page or the current flow, depending on how you want to do it. But before you import it, you do need to make sure you do have on your system is the nodered dashboard, the old school one and the new school one. Because when you try to import it, it just won't come in properly. All these nodes here, all these blue nodes, there'll be white and it'll say errors, because you need to have the nodes imported from the palette. So you'd have to go into manage palette, installed, and then you go dash board. Unfortunately, it's going to be ended soon, but you just install it. They have brought out the nodered dashboard too, but just install it. It will work for another sort of 10, 11 months. And to be honest, they probably won't get rid of it. It's just not getting updated anymore. So, but then you go back. So these are the 4 nodes that make this screen here. So if I change that, now I'm set at 12 and it's dropped down to 12. Change that to it's having a moment, as it always does. Sometimes my screens need refreshing. There we go, that's close enough. But yeah, so then if I want to turn the heating off, I click down here, turn it off, and it should, where it's heating mode, now it says it's off. And then you can hit 0 as well over here. But this is what shows up on the screen. Plus the room temperature and the hot water temperature are pulled in from a bit further down here. I've created these few nodes here. Ignore these ones, these are me playing around. I'm just having a little play with some of the nodes to see what I can do with them. Don't know what that one's doing. Oh, it's about my API key. I'm not going to show you that because you don't show people your API keys. So then the hot water, you create a virtual device, and the room temperature, create a virtual device, and then you pull the information from the Truma and the hot water temperature and the room temperature, and then you just dump them details into there. So if I click on that, there's my node page gone, and hit debug, close that, probably only set to come in if it changes. Yeah, that's to do with the hot water, and so these two then appear on the Cerbo screen. That's what makes them appear here. And it's pretty handy to keep an eye on your temperatures of your water and so on. I haven't got any tank sensors fitted. I haven't bothered really. I've got gauges on the tops of my tank, and I'm always, if I ever go out, I always fill up. I don't mess around, I just fill up when necessary. Okay, so that's it for now. If anybody wants any more information or information on where to get the GitHub repository from, just drop us a message in the video, and I'll drop you a link. Okay, bye bye.